So our next example is to write this general form equation in standard or vertex form. Okay, so this is what you guys all love. In order to do this, we're going to have to complete the square. So the first thing I want to do is I want to knock this 8 over with the y. Then I'd like to look at these two terms that are left on the right-hand side that both have a variable and ask myself, what number can I take out of both of them? Well, here that's a -1. So I have y minus 8 equals -1 times x squared plus 2x. Here comes the completing the square part of it. So I need to create a third term in there that's going to allow this to factor beautifully into the same thing times itself. Okay, so to do that, I go to this x term right here, which is the 2x. I take that 2 and I split it in half. Half of 2 is 1, and then I square 1. 1 squared is just 1. What I do to one side, I have to do to the other, but we have to make sure that we break out of the parentheses first. So I have to undistribute the -1. 1 times a -1 is -1, so that's what I'm adding over to the left-hand side. I go ahead and simplify farther, so I get y minus 9 equals -1 times the x squared plus 2x plus 1. I could go ahead and factor that right-hand side right there. And when I do, I get y minus 9 equals -1 times x plus 1 squared. And then that is my standard or vertex form. So then you're probably asking, when are we ever going to use this? So let's find out. We're using the story of a projectile that's being launched from a height of 600 feet above ground. Our height equation is given to us in terms of time as -16t squared plus 803t plus 600, where t represents the number of seconds after it was launched, and h of t is the height after that many seconds. Part A is just asking us to estimate when the height is going to be 5,000 feet above ground. This means I'm going to take this 5,000 here, and I'm going to plug it in for h of t. So I have 5,000 equals -16t squared plus 803t plus 600. Well, I know in order to solve this, I'm probably going to have to make sure it's written as a quadratic, so I need to subtract the 5,000 over and set it equal to 0. When I do that, I get -16t squared plus 803t minus 4,400. From here, I can go ahead and do my quadratic formula. I know they're big numbers, but it is what it is. So when I do the quadratic formula, I get -803 plus or minus the square root of, I plugged it all into my calculator and got 363,209 under the square root, and then divided by a -32. It's okay to have decimals here, so I'm just going to go ahead and take the square root of 363,209. And when I do, I get -803 plus or minus 602.6682. Make sure you take 4 decimal places on any decimal. Over -32. I go ahead and I split it into an addition and a subtraction problem to get my two answers of 6.2604 and 43.9271. So I don't understand. How do I get two answers for a height? Well, if you know anything about a projectile being launched, I know that after it's launched, it has to come back down. So if this is 5,000 feet right here, that means my projectile passed 5,000 feet, hit its peak, and then came back down. Okay, so it first hit 5,000 feet at 6.2604 seconds, and on its way back down, it hit 5,000 feet again at 43.9271 seconds. So those are our answers for part A. You would just say t equals, we can say 6.3 for an approximation, and then 43.9 as well for an approximation. Part B then is going to kind of go off of this graph. Part B is asking us, determine when the projectile is at a height greater than 5,000. Well, Well, we already did all the hard work. We figured out when it hit 5,000, which means that between where it went past and where it came back through, it had to have stayed above 5,000 feet, which means that t greater than 6.3 but smaller than 43.9, that whole time it was above 5,000 feet. Okay, because that's what my graph is showing me. I could also write this as 6.3, 43.9. Why am I using parentheses instead of hard brackets? Because it said more than 5,000 feet, not exactly, or more than or equal to 5,000 feet. Okay, so I know at 6.3 and at 43.9 it was 5,000, which means after those, or between those, sorry, is when it was above 5,000. Part C asks, how long will the projectile be in flight? Which is basically just asking, how long will it be before that projectile hits the ground? And if it hits the ground, it's clearly at a height of 0. Okay, so what I need to do is I need to plug in 0 for h of t, and I need to use my quadratic formula again to solve. So I have 0 equals negative 16t squared plus 803t plus 600, because that was the original height in terms of time equation I was given. I go ahead and I plug it all into my quadratic formula. When I do that, I get negative 803 plus or minus 826.5646, all over a negative 32. This splits into two answers, one addition and one subtraction. So my two answers are negative 0.7364 and positive 50.9239. Are both of those valid answers? No, I can't have a negative amount of time, and each of these answers is the amount of seconds it would take for it to hit the ground. So this is not an acceptable answer, but this one is. So it would take 50.9 approximately seconds in order for that projectile to hit the ground. Okay, homework's on Canvas. Let me know if you have any issues.